In this video, we are going to show you our investigation on rate of corrosion. We attempt to compare the rate of corrosion of two famous limestone structures by acid rain in order to better protect them. We have identified three variables that affect the rate of corrosion, which are air temperature, pH value of acid rain, and surface area of limestone architecture. For our research data on temperature, an assumption was made that average temperature yearly of the respective locations can be used as representative for the experiment. As we calculated, the average temperature in Rome, Italy is 16.7 Celsius degree, and the average temperature in Uttar Pradesh in India is 25.9 Celsius degree. The chemical reaction showing the formation of acid rain is shown below. As pH of the rain is determined by the concentration of acids, it is then determined by the concentration of sulfur dioxide and nitrogen dioxide in air. As we are unable to find any data on pH value of acid rain in two places, we use the average concentration of sulfur dioxide and nitrogen dioxide in air to compare the pH value. Daily concentration of sulfur dioxide and nitrogen dioxide in air of these two areas are obtained from a website that access to local air quality monitoring station. The average concentration of the two gases in air are shown in the table below. From the table, we can observe that the concentration of both sulfur dioxide and nitrogen dioxide in air of Rome are lower than that of Uttar Pradesh. Hence, acid rain has a higher pH in Rome than in Uttar Pradesh. With the increase of concentration of hydrogen ions and thus the concentration of an acid solution, the pH value will drop. The reason why we choose pH value as a variable instead of concentration is because pH is very easily measured and commonly used. Our conclusion hence will be more applicable, but for the convenience, the following discussion will be based on concentration of an acid solution. Based on calculation, the surface area of these two architectures are shown here. It's obvious that the Colosseum has a larger surface area than the Taj Mahal.
Our objective of the experiment is to investigate how the three variables, temperature of the acid rain and limestone, concentration of the acid rain, and the surface area of the eggshell will affect the rate of corrosion of limestone. Our methodology is to carry out experiments for all three variables by using eggshells to represent the limestone and vinegar to represent acid rain. The independent variables of each experiment will vary accordingly to the aim of the experiment we are carrying out. We will then calculate and compare the average rate of reaction and come to a conclusion. This experiment that will be conducted is the control experiment. The purpose of this control experiment is to ensure that the changes in the rate of corrosion during each experiment is only affected by the variable that the particular experiment is trying to investigate. The second experiment investigates the effects of concentration of acid rain on the rate of corrosion of limestone. In this experiment, the vinegar will be diluted by reducing the amount of vinegar used but replacing the remaining volume with distilled water. From this experiment, we will then be able to see the effects of the different concentrations of acid rain on the rate of corrosion of limestone. The third experiment investigates the effects of temperature of acid rain and limestone on the rate of corrosion of limestone. In this experiment, the conical flask containing the vinegar and eggshells will be left in the beaker containing ice cubes to reduce the temperature of the vinegar and ice cubes to 0 degrees Celsius. From this experiment, we would then be able to see the change in the rate of corrosion of limestone between this experiment and the control experiment. The fourth experiment investigates the effects of surface area of limestone on the rate of corrosion. In this experiment, the eggshells will not be crushed like the previous three experiments, but instead we will use large pieces of eggshells. We will then be able to observe the change in the rate of corrosion of limestone when there is a change in the surface area when we compare the results of this experiment to that of the control experiment.
In the context, the average temperature of Rome is 16.7 Celsius degree, while in Uttar Pradesh is 25.9 Celsius degree. The reason why we choose room temperature and 0 Celsius degree in experiment C instead is because, firstly, it's very difficult to make the vinegar solution have such contactual temperature, plethora time and efforts are required. Secondly, it's impossible to make the temperature of vinegar solution remains at contactual temperature because of continuous thermal conduction. If the temperature gradually increases to room temperature, our result will be affected seriously. However, by using room temperature and 0 Celsius degree, the temperatures are able to remain the same all through the experiment. Independent variables, dependent variables, and constants of each comparison are shown here. Our choice of apparatus is shown here.
The following is the reason why we chose the 200 cm3 measuring cylinder. For the control experiment, step 1, pour both the 3 grams of crushed eggshells and 40 cm cube of vinegar into the conical flask. Step 2, insert the rubber tubing into the opening of the conical flask and start the stopwatch and record the results. Carry out the experiment for 5 minutes and record the results once every 30 seconds. For the experiment on temperature of acid rain and limestone, repeat step 1 of the control experiment. Step 2, put the conical flask into the beaker containing ice. Step 3, insert the rubber tubing into the opening of the conical flask and start the stopwatch and record the results. For the experiment on the concentration of acid rain, step 1, pour 20 cm cube of vinegar and 20 cm cube of distilled water and 3 grams of crushed eggshells into the conical flask. Step 2, insert the rubber tubing into the opening of the conical flask and start the stopwatch and record the results. For the experiment on the surface area of limestone, step 1, pour 40 cm cube of vinegar and 3 grams of eggshells that are not crushed into the conical flask. Step 2, insert the rubber tubing into the opening of the conical flask and start the stopwatch and record the result.
Table showing reading of measuring cylinders against time are shown here. Average rate of reaction is calculated by volume of carbon dioxide produced divided by total time. For experiment A, the average rate of reaction is 0.170 cm3 per second. For experiment B, it is 0.0867 cm3 per second. For experiment C, it is 0.0433 cm3 per second, and for experiment D, it is 0.0400 cm3 per second. From the comparison, we can infer that with the increase of pH value of vinegar solution, the rate of reaction will decrease. With the increase of temperature, the rate of reaction will increase. With the increase of surface area of eggshells, the rate of reaction will increase. The effect of surface area on rate of reaction is the smallest. However, it is observed that after the reaction started for a while, the rate of reaction increased drastically. A graph showing this phenomenon is shown here. This is because neutralization is an exothermic reaction. Heat will be released from the reaction. As such, an assumption needs to be made that we can neglect the temperature change due to its exothermic property.
In room temperature, the calcium, carbonate, ethanol, and hydrogen ions are moving rather rapidly. The ions have high kinetic energy and hence there are higher chances of them colliding into one another, leading to higher chances of effective collisions between the ions. In temperatures as low as 0 degrees Celsius, the ions are moving at a very slow pace. The ions have very low kinetic energy and they
there is a
seldom
lower frequency
collide.
of successful collision between the different ions, as the surface area in contact with the acid is smaller. Hence, the rate of reaction is slower. From the animation 2, we can see that the eggshell is crushed and hence incomplete. Compared to the complete eggshell in animation 1, we can see that this eggshell has a bigger surface area and there is a higher frequency of successful collision between the different ions as more surface area is now exposed to the acid. Hence, the rate of reaction is faster.
As we have discussed in research data part, pH difference means difference in concentration of hydrogen ions. An animation showing the submicroscopic view of reactions will be shown to explain the differences in rate of reaction by collision theory. Notes: since water molecules exist in large number and they are now involved in the reaction, they are now shown in the animation. Concentrated solution is shown on the right and dilute solution is shown on the left. From the animation, we can see that at a higher concentration, there are more hydrogen ions per unit volume. Frequency of collisions between the hydrogen ions and carbonate ions increases. This results in a higher frequency of effective collisions, hence an increase in rate of reaction. As we have discussed the relationship between concentration of hydrogen ions and pH value, we can hence conclude that the rate of reaction will increase with the decrease of pH value of aqueous solution. From the previous part, we can conclude that with the increase of temperature, surface area of architecture, and decrease of pH value of acid rain, the rate of corrosion will increase. We can also conclude that the effect of surface area on rate of corrosion is the smallest. Since Taj Mahal has a smaller surface area but greater temperature and lower pH value of acid rain, the rate of corrosion of Taj Mahal is higher than that of Colosseum.